naming. It feels like we've been naming forever, hey? Like we've learned how to name ionic compounds and polyatomic ions and all sorts of different things and covalent compounds, but we're not actually done yet. You see, chemistry has such a wide variety of things, and we like to make sure that we communicate clearly in chemistry. And so every type of molecule has its own naming system. Today, I'm going to introduce to you another naming system, and this is the naming system used for acids. Now, I know when you think acid, you probably think like it's going to eat through your skin and melt through the floor, but that's not really what acids are. Like some can do that, sure, but a lot of them are just like harmless things that you are around all the time. And what I wanted to introduce to you what the idea of an acid is very first. So an acid is first of all a covalent compound because an acid always has hydrogen in it. You see, all acids are a hydrogen combined with some negative thing. And so we often talk about like this as HX, where H is the acidic part and this is what it's combined with. So to give you some examples, there's things like HCl, H2SO4, HNO3. But you notice all of them have H at the beginning. You see, acids may be a covalent compound, but we treat them like they're ionic because it's just a lot easier. And the way that they work lends itself to this thinking. So here's the way that we think about acids. We think about acids, and since we think of them as ionic, our naming system lends itself to this thinking as well. And so the way that we name acids is entirely based on the ending of the name of the anion. Okay, let's take a look. So what I mean by that is there are essentially three different scenarios. So we're going to look at scenario 1. And in this case, we have an anion, so a negatively charged thing, that ends with IDE. So to give you an example, this would be something like chloride. So chloride is Cl-. Typically what we're talking about is monoatomic anions, single atoms with a charge. So here's what we do when it comes to using these. If this is our scenario where we have an anion that ends with IDE, what we do is we add a prefix. So number one, we're going to add the prefix hydro. So if I'm dealing with chloride, what I would do is in front write hydro, and so it looks like it says hydrochloride. The second thing I do is change the suffix or the ending to ic. So instead of writing chloride, I would write chloric. And the last thing we do is we add the word acid. So this becomes hydrochloric acid. So when we're naming an acid, what we want to do is look at the ending of the negative part's name. And if we see that IDE, the real key here is use the prefix hydro. In the reverse, if you see the prefix hydro, it actually tells you that the negative part of that acid had to end with IDE. So it's kind of a handy system, although complicated, to help us understand what an acid is actually made out of. So we're going to work through an example of this. I've been given this compound HBr, and I want to figure out how I would name this substance. So the first thing you want to do is recognize H in front. H in front automatically tells me, okay, this is an acid. And as soon as you recognize H in front, this should be setting off alarm bells because it means you have to name it differently. Because you know it's an acid, here's what we want to do is we want to look up Br and figure out what it's called. Well, Br is called bromide. And here's our key. Ending of the negative part is IDE. So we need to follow the rules that we learned, and we're going to add the prefix hydro. We're going to keep the main part of the name, brom. We're going to change the ending to ic and add the word acid. So HBr is actually hydrobromic acid. So this is how we would go about naming it. Recognize it's an acid with the H in front, look up the negative part and what its name ends with, and if it ends with IDE, we add hydro, change the ending to ic, and add the word acid. But what if we wanted to do this in the reverse? What if I were to give you the name of an acid and we wanted to figure out what that acid's formula was? So here is going to be the example that I give you. Let's say we were given the name hydrofluoric acid. What you want to do is first of all recognize, okay, acid, it's going to have H plus at the beginning. That's what this should tell you right away. And so now we know we're just looking for the negative part. So I recognize, okay, hydro and ic. This tells me that the ending used to be IDE. Fluor, so fluor is the original part of the name, and I'm looking for fluoride, and fluoride is F minus. So now to figure out my formula, I just need to combine these two. Since hydrogen has a positive one and fluorine has a negative one, I get HF. So this is scenario one. This is when we're dealing with an acid that ends with IDE, but there are two more scenarios we need to look at because there's a lot of other negatively charged things. So the next thing we're going to look at is when we have the ending ATE. So in scenario two, we're dealing with an anion that ends with ATE. And so let's give this example. Let's say we're talking about NO3, so HNO3. Because it's an acid, it has to have that H in front, and NO3, if we take a look, is called nitrate. And so we get that ATE ending. We also know this is an acid again because it has that H in the front. So here's what we are going to do when it comes to naming this acid. Whenever you notice that it has ATE at the end of the name, you're going to change the suffix to ic. Let me space that out so it's easier to read. We are also going to add the word acid. So when we're dealing with nitrate, we're going to change that ending, ATE, to ic. And we're going to get nitric, and then we add the word acid, so nitric acid. You may be wondering, how is this any different from the last one? Well, when it ends with ATE, there is no prefix, and that is really ultimately the key here. There is no prefix. So I know it seems really fickle, and I know it seems really tedious, but that is the rules. And I didn't make the rules. We just follow the rules. The rules were set out by chemists and people who do this for a living. And so this is what they've been doing for like 100 years, so, or more. And so that's why we follow it, is we just go with a consistent set of communication so that everybody knows what we're talking about, even if that means it's a little bit confusing to learn. Okay, so let's do some examples around this idea of using the ATE ending or the IC ending to help us understand some different acid names. So I'm just going to clean this up a little bit, and then we will take a look at some different acids. So let's say I'm looking at something like H2SO4. So first of all, recognize it's an acid with the H in the front, and then take a look at the negative part, and we notice that this would be called sulfate. Just a heads up again, I use British English, so I use PH instead of F, but if yours says F, it's still the exact same thing. So sulfate ends with ATE, so we need to keep the beginning of the name. Now, just a heads up, when we're dealing with sulfur-based compounds or polyatomic ions, they always keep a UR. So this would actually become sulfuric, and then we add the word acid at the end. So sulfate becomes sulfuric acid. I know that's kind of weird. I wanted to do this example to explain it to you, but that's the case for both sulfur and for phosphorus, where we keep the or sound. So we get sulfuric acid or phosphoric acid. Again, I don't know why. We just do. That's the way it goes. So that is how we would do this, but let's take a look at how we might name something else. So let's say, or maybe write our formula. So let's say we had carbonic acid, and we wanted to be able to figure out what is the formula for it. So again, recognize it's an acid. It's going to have H plus in the beginning. It has no prefix. That's what we need to look for. And it ends with ic. So we know it used to end with 8. And so we're looking for carbonate. So carbonate is CO3 with a -2 charge. So we're going to combine this together, and you'd have to do your swap and drop here to balance out all of the negatives. So you have 2 negatives. H only has a +1, so you need 2 H's to balance out that name. So those are 2 of our naming systems. When it ends with IDE, we had hydro, end with ic acid. If it ends with ATE, no prefix, just end with ic acid. But there's one more scenario. And this scenario is when we're dealing with things that end with ITE. So let's take a look at an example here. Let's say I had NO2, and it's going to have an H in front. So HNO2. Again, we want to recognize, okay, H in front, that has to be an acid. So use my acid naming rules. Look up what NO2 is. NO2 has to have just a -1 charge because there's only 1 hydrogen. And this is called nitrite. It's the stuff that everybody seems to be afraid of being in their bacon for some reason. So nitrite, because it ends with ITE, we're going to follow a different set of rules. So what we're going to do is change the ending to OUS, and then we are going to add the word acid. So when I'm dealing with nitrite and I'm writing its acidic name for HNO3, what I would write is nitrose acid. You see that ITE ending becomes the OUS ending. The other thing I hope you notice here is there is no prefix. So the prefixes are only for the IDE ending. So again, I know this may seem kind of cumbersome, and I know it may seem kind of confusing that we have all these different naming rules and systems, but that's the way that it goes. So let's do a few examples before we finish up, just to make sure we're clear about using this final scenario. So what we want to do is we want to take a look at an example where we have that ITE ending. And so let's say we had something like H3PO3. So again, what you would want to do if you're working on this is notice, okay, I've got H's in the front, dealing with an acid. Follow my acid naming rules and find PO3 on my list of polyatomic ions. And I notice that it's PO3. It has to have a -3 charge because of the 3 hydrogens. And this is called phosphite. That ITE ending is the important part here for us, because that ITE ending is going to tell us how to name it. So we're going to change that ending to OUS, and we're going to get phos. Now remember what I said, phosphor for phosphorus-based compounds, or sulfur if it's a sulfur-based compound. And then we add OUS. So phosphoros, and then we add the word acid. Right, so change that ending to OUS. Okay, let's think about another example. Okay, so what we're gonna do is we are going to write the formula for chloros. Oh, forgot my R, chloros acid. Okay, I know this may seem redundant because I've done it, but when you're naming things and they're all jumbled, it's important to recognize these little clues. So acid, H in front. Ose, it's going to end with ITE. So we're looking for something called chlorite. So chlorite is ClO2 with a -1 charge. And that is our formula for chlorite. Now, we're going to combine those together. You have a +1, -1. That balances out. And there's our formula for chloros acid. And that's it. That's all the naming rules. So we've gone through ionic compounds, we've gone through covalent compounds, we've gone through acids. And for now, that's really good enough. The big thing here is it's important to practice, but I really think at this point, once you feel comfortable with it, practice something where they're all mixed together, where you actually have to make that identification. So remember, if it's got metals in it, it's going to be ionic. If it has 2 nonmetals, it's covalent. And if it has H in the front, it's an acid. It's really important that you can make those recognitions, because you have 3 different sets of rules so that we can identify the type of compound that we're dealing with. So I hope this helps you learn how to name compounds. But again, please practice. Please ask if you're unsure. And thanks for watching.